Okay, so our learning target for today, again, we're still focusing into our ratios and proportions unit on our scale drawings and scale factors. So today we're going to practice actually drawing scale copies. So that is our learning target. I can draw a scale copy of a given figure using a given scale factor. Now remember, when we are creating a scaled drawing, we take an original and we multiply it by the scale factor, and that will equal your scaled drawing. So that was when we were trying to find the scale drawing, we knew we used division, or when we were trying to find our scale factor, we used division. When we're creating our scale drawing, we use multiplication. So write that at the top of your paper. You're going to take your old and you're going to multiply it by your scale factor, and that will equal your new. Because remember, we could take new, divide it by old, and that gave us scale factor. It's kind of like working with equations, you do inverse operations. So our old values multiplied by the scale factor is going to equal whatever our new value is going to be. So we're going to draw a scaled copy. It says to draw it of either A or B. It really doesn't matter which one. I'm going to do A with you. You're going to do B on your own to just get some practice. So the first thing that I want to go ahead and do is identify what my values are going to be. Now I don't know my diagonal value. I can't identify that, but I can identify values that go up and down. So for here, I do have, and actually we'll just go focus on A. We're just going to focus on A for today. And I do have this measurement being 2. I have the height, the vertical height is going to be 3. And the horizontal bottom base is going to be 3. Now, I don't know what the diagonal is going to be, so I'm just going to have to draw out this information to figure it out. So what I'm going to do is I'm going to take each of these components, the 2, the 3, and the 3, and I'm going to multiply it by my scale factor. What was my scale factor again? 3. My scale factor is 3, so I'm going to multiply each of these by 3, and that's going to come out to my new dimensions. What's 2 times 3? 2 times 3? 6. And 3 times 3 is 9. So we'll get dimensions of 6, 9, and 9. So when I'm drawing this, I'm going to go ahead and go 6 apart. So 1 box, 2, 3, 4, 5, 6. Then I'm going to go 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to go 6 across, or I'm sorry, 9 across. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I can connect these, and that's going to be my diagonal. Okay? What I want you guys to do is you're going to go ahead and do a scaled copy on the next one for C. We're just going to do a scaled copy for C. Do that one on your own. Identify your measurements for each of the side measurements that you've got, and then you're going to multiply them by your scale copy or your scale factor of 1/2. That means you're going to take half of it. All right, let's go ahead and take a look at problem C. So again, we want to identify all the dimensions that we can in order to be able to properly graph this. So let's start with our very first tall vertical height. How many boxes does this tall vertical height cover?
7.
7. Okay, and then what about this top 2? Then this next line dropping down is 4. This line right here is 3. This little line right up here is 2. This one little line is 1. What is this line? 5. And then this line here. it's,
Wait.
let me see
Yeah, I
here.
got 6.
1, 2, 3, 4, 5, 6. Yeah, 6.
Yeah.
Okay, so we're making a mistake somewhere. 1, 2, 3. No, we got it. It's 6. All right. So there's all of the information. So again, what we want to do is we want to take all of those pieces and we're going to multiply it by a scale factor of a half. So I'm going to take this 7, this 2, this 4, 3, 2, 1, 5, and 6, and we're going to multiply all of them by the scale factor of a half. God bless you. Okay, every one of these gets multiplied by a scale factor of a half, which means that we're going to be dealing with some of these that are not going to go a full box. They're just going to go half of a box over, and that's perfectly fine. If we do 7 times a half, then that's going to come out to 3 and a half. If we do 2 times a half, that comes out to 1. 4 times a half is going to come out to 2. 3 times a half is going to come out to 1 and a half. 2 times a half again comes out to 1. 1 times a half comes out to a half. 5 times a half is going to come out to 2 and a half. And then 6 times a half is going to come out to a 3. So those are going to be the new dimensions, the new measurements for the shape that we're going to be creating. Okay, so I'm going to start with my vertical. My vertical is now only 3.5 boxes, so I'm going to go down 1, 2, 3, and then halfway down the box. All right, for my bottom measurement, that now becomes sorry, we'll go in order. We'll go from the 2. So we'll go up at top. We're only going to go 1 box over. This 4 now became 2 boxes. So 1, 2. This 3 across now comes out as 1.5 across. So 1.5. Then we're supposed to go up 2 boxes, but we're going to go up only 1. Then we're going to go across half a box. Then we're going to go down 2.5 boxes, so 1, 2.5, which happens to line up perfectly here. And when we connect those, that creates 3 boxes that connect across. Okay, so there's our scaled down. It was scaled down, made a reduction. Again, the reason it was scaled down is because our scale factor is smaller than 1 whole. If our scale factor was larger than 1 whole, like the first example we did, it's going to make an enlargement, makes it bigger. Okay? Any questions? All right, go ahead and flip it on over to the back. On the back here, it says that Jada wants to scale the polygon so that the side that corresponds to 15 in the original, so here's where 15 is. Here's 15, that's my original, which means it's going to be this measurement right here. We want to scale the corresponding 15, so that the side that corresponds with 15 in the original is 5 units in the scaled copy. So we want this 15 to now become a 5. That is not the scale factor, that is now the scaled item. So that's our new. This was our old. This is our new. How do I find the scale factor? What do we have to do again to find scale factor? Kyla?
Divide the original by new.
Reverse. New divided by old. It's always going to be new divided by old. Let's write that at the top again. New, and we're going to divide it by the old, and that's going to give you your scale factor. And just as we covered up in the front at the very beginning, if we were to take our old and multiply it by our scale factor, then that's going to equal our new. So the first thing we need to do is we need to figure out what is our scale factor in the problem. So we're going to take our new, our 5, and we're going to divide it by our old, our 15. Be mindful, we're not doing 15 divided by 5. We're doing 5 divided by 15 to find the scale factor. So for our scale factor, we're going to take the 5 and we're going to divide it by the 15. When we do 5 divided by 15, what do we get?
2.3.
Not 2.3. 1/3. We get 1/3. Our scale factor is going to be 1/3 or 0.3 repeated. So there's our scale factor. So what that now means is we're going to take every one of these old dimensions and we're going to multiply them by 1/3. We're going to take all of this old, this whole thing is our old, and we want to find out what our new is going to be. We're going to take the old information and we're going to multiply it by 1/3. That's going to give us our new information. So I'm going to take 36 and multiply it by 1/3. I'm going to take 18, multiply it by 1/3. I'm going to take 12 and multiply it by 1/3. Take 21 and multiply it by 1/3. Take 30 and multiply it by 1/3. Okay, so let's start with the very first one. 36 times 1/3 is going to give us what? 36 times 1/3 is what? 12. 12. 36 times 1/3 is 12. Just think of it. If we're multiplying by 1/3, it's like we're dividing by 3. So 36 divided by 3. If you've got your computers open, please close them. Okay. 18. If we do 18 times 1/3 or 18 divided by 3, what does that come out to? 6. If we do 12 times 1/3 or 12 divided by 3, that's what? 4. Okay. 21 divided by 3 is 7. And 30 divided by 3 is 10. So there's our new dimensions of our scaled down, our reducted or reduced scale drawing. Okay, I want you guys to do the same thing for the L shape. Identify what the old measurements are, and then you're going to draw a scaled copy using the scale factor 2/3. All right, real quickly, let's go ahead and go over this one. So our original measurements, the base was how long? 6. And what was the height? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, 9. Okay, so if we are multiplying, we're multiplying this by a scale factor of 2/3. So we're going to do 9 times 2/3, and we're going to do 6 times 2/3. When we do 9 times 2/3, that's going to come out to what? 6. So 9 times 2/3 means that we're going to have a new dimension of 6. And what's 6 times 2/3? 4. So we're going to have a base of 4. So we're going to go down 6. 1, 2, 3, 4, 5, 6, and across 4. 1, 2, 3, 4. So this is what our new scaled drawing is going to look like. For our last question, what we're going to try to do is we are wanting to figure out which of these sets, and there's multiple sets that could be potential scaled copies of this original. So this is the old. I want to know which one of these are able to be new versions of that old. So that means that you're having to check each and every one of the points. You have to see, this is 4, 7, and 10. Here we have 8, 11, and 14. We want to see if they have identical scale copies throughout. So that means for problem A, I'm going to work the problem A off at the side. That means I'm going to take the 8, or sorry, oops, that should be the new, that should be in pink. I'm going to take the 8 and divide it by the 4. I'm going to take my 7 and divide it by, or sorry, my 11. Miss French-Zheng's having a little hard time today. And divide it by 7. I'm going to take the 14 and divide it by 10. If it is a true scaled copy, all of these will come out to being equal. If I do 8 divided by 4, that's going to equal 2. But if I do 11 divided by 7, that's going to come out to 1.57. It's going to keep going on. These, and then if I divide 14 divided by 10, that's going to come out to 1.4. These are not the same. These are not equal to each other. So that means A is not a scaled copy. You're going to test that for each one of these with your table mates. You're going to check every single one. Remember, you take the new and divide it by the old. Take your news and divide it by the old. If they are the same throughout the entire problem, all sides have the same scale copy, then it is a scaled version. There are 3 of them that are scales. Go ahead and find it. Okay, let's wrap it up. Come back. All right, let's go ahead and go over these. So for problem B, again, we're taking all of the new measurements. Our new measurements are 10, 17.5, and 25. And then we're going to divide them by all the old measurements. What are we going to divide the 10 by? 4. What are the 17.5? 7. And then the 25? 10. We're going to divide it by the 10. Okay? When we do so, 10 divided by 4 comes out to 2.5. 17.5 divided by 7 comes out to 2.5. 25 divided by 10 comes out to 2.5. So this is a scaled copy. This is considered to be a scaled copy because they do all come out to the exact same value. So that is one of our scaled copies. Now let's check the next one. We're going to check C. Give me your agenda. All right, for here, our new values are 6, 9, and 11. Again, we're going to divide them by the olds, which were 4, 7, and 10. When we do 6 divided by 4, that's going to come out to 1.5. But when we do 9 divided by 7, that's going to come out, 9 divided by 7 is going to come out to 1.29. And then 11 divided by 10 comes out to 1.1. These are not equal to each other. Because they're not equal, then that means it's not going to be a proper set. Okay, I'm going to move over to the side over here to do problem D. For problem D, taking our new, which was 6, 10.5, and 15, and we're going to divide it by the old. So we're going to divide it by 4, divide it by 7, divide it by 10. When we do so, we're going to get 1.5, 1.5, and 1.5. They all come out to the same, so D is a proper set. Okay, the last one that we're going to check is E. We're going to take the new values, the 8, 14, and 20. 8, 14, 20. We're going to divide it by our old values, so divide it by 4, 7, and 10. Each one of these is going to come out to a value of 2. So that is also a proper scaled drawing. Yes? Huh? Oh, so I'm so sorry. Okay, so this is what you would do in order to be able to find whether or not something is a proper scale. You have to make sure that it's a consistent scale throughout the entire problem. You need to make sure that if you are taking an old value and trying to create the scale, you would multiply your old values by your scale factor. Okay, so division is how you find the scale. Multiplication is how you create a drawing, a scaled replica. So what you're going to be doing today in your groups, you're going to be doing a pass it along or a pass around. It's just front and back on your sheets. Each person is responsible for their own sheet. And they are color coded. Color coded. Okay, and we're going to go over that right now.